Hello again guys, back to day 17 part 2. I imagine you remember this sort of a tower that we built. It was built by throwing rocks at it. You can think of it as a tower or a well, whatever you prefer. The whole idea was in part 2 we have to calculate the same thing but for a 1 trillion rocks. Which is kinda a lot, to say the least. And I'm more than sure that day 1 solution would actually work in this case. It would just take us a lot of time. I actually tried it, and it's taken a lot of time. Let's end it there. So what I tried a few things. So pretty early on, I caught up to the fact that we're looking for sort of a pattern in here with that rock falling. In my solution, I've got two main things. One was air jets, which was the source of the air blowing in different directions, and also the rock source. And that is obviously a source of rocks, so it handled which rock was falling down next. So I figured if we have, for example, 10 of those and 5 of those, we should be looking at a combination of those two, so 5 times 10 equals 50. And I actually tried to run with it for a while before I realized that actually air jets are changing between steps of the rock. So it's not really like this. That will not work. Then what I was trying to figure out where or when the move will repeat. Because if we are looking for a pattern, we are looking for repetition, right? So I quickly realized there are 3 things that if they all line up, we've got a repetition in here. So first of all, for that air jets, we have an index. I realized the same situation happened with rock source, because once again, if we are looking at the same index, with both of those at the same time, we are closer to the repetition. And then in the end, there's also the shape of the map, or rather the shape of the top of the map. So when we gather those 3 things, then we are sure the next moves will be identical to what was happening before. If those things are important, I'm actually using, or rather representing the shape of the map incorrectly, because I was always remembering the map and always was taking like top 50 levels of the map, right? What I decided to switch to was really just holding on to the top of the map until we see a floor of sorts. That's why it made more sense to cut the map from the bottom and just adjust the indexes. Adjust the indices, adjust the y coordinates. So my plan was pretty simple. Cache those 3 items and just run the algorithm. Whenever you find the same situation, well, you already have the output, or you know what's gonna happen next. This is actually a correct solution. However, it still took about 3 seconds per 1 million of rounds. 3 mil of seconds, which corresponds to roughly 830 hours. Which is still a little bit too long to run it, so I decided not to. I couldn't really figure out anything else on my own, so I went to Reddit and I went to read, well, not really solutions, but rather the ideas. I wanted to understand how did they approach the issue. Like, everybody mentioned cycles, and I couldn't really figure out what was that because I didn't want to read the solutions yet. And there was one particular comment. Unfortunately, I didn't write down who was the author of the comment, but the comment pretty much went like this. After I saw repetition happening in the data, it was easy to see the cycles. So I decided to debug my solution and decided to understand those cycles or those repetitions, how they happen. And when you go into debugging with this, you actually see two things. For the first 63 rounds, you just happen to have always a new situation, always a new snapshot. After you hit number 64, it actually repeats last 35 rounds or 35 rocks, which actually meant those 35 moves are our cycle. And this is what everybody was talking about. So yeah, you have some initial rounds to set up the well or the tower, and then you've got only 35 moves which will happen on repeat. So as you can imagine, it's actually quite easy when you see that to repeat it as many times as possible, because if we are looking at 1 trillion, you just have to divide that by 35 and, well, just be done with it. That's the whole idea. Okay, so let me tell you what really changed in this. I separated the logic for inner progress for a single rock, and this is in here. There's one change in here because I had to record somehow how many times we actually used airjets next, because this will allow us to repeat that in our state. So yeah, airjets advance is the only real change in here. However, the whole how tall tower function is quite a lot different. So first we have the map snapshot input, and those are the three things I mentioned, right? So there's the airjet index, the rock source index, and also the current height. And this is, as you can see, a vector, so it actually represents the current height of each of the X besides the wall. What we have as an output is actually a shape of our whole map, the height that we gained from cutting the bottom of the map, and also how many times the airjets advanced, or how many times it was next in there. Later on, I also added this thing. It was not initially in here, but it made things a lot easier for me. So this is also the next state. This is pretty much pointing to the next step of the whole 35 cycle. Apart from adding the rock map snapshot repo, there's nothing really new in the beginning. I also added the height counter, because as I mentioned, we are now recalculating the map each time we cut something from the bottom. Okay, so the first step is to create the map snapshot input, so we can check whether we already cached this situation or not. The first 63 rounds will happen on repeat just in here. So it will just simulate the rock falling, and it will fill in the rock map snapshot repo, so we have actually the data in. Then on that 64th round, we will actually find that initial snapshot. And this is where the situation changes dramatically. So whenever we find the snapshot, we take care of the index, we also take care of the rock source, we also know the map state after this step, so we are actually grabbing a reference to that map. We also grab the reference to the next step, because the initial snapshot already has a next state. And possibly that next state is also in the repo already. If we are still finding that next step, we will just continue and continue and continue, right? So we need to stop the algorithm. And this is where the fun begins, because if our next step would be the same as the map snapshot input, then we are looking at a whole cycle. Then we calculate how many cycles we can run fully I'm doing a lot of operations in here, as you can see, for the rock source, the airjets advance, height counter, and so on. I'm doing quite a lot of that, and in the end, I do adjust all of those things. But actually, looking at the pure data, this is not really needed, this is not required. We actually don't care about how the map will look after that. And this is not something that is obvious, and this is very specific to this situation. So I just in case still left the whole calculation. Imagine a new part of that task where after those 1 trillion rounds we would have to continue, I would be able to do that. And that's it. That's the whole spiel. So now if we go cargo test, boom, it's already green, like it's really freaking fast. And if you go cargo run in release, boom, that's it. That's how long it takes now. It's not 830 hours, certainly. Thank you very much, guys. I'm happy you've been here, and as always, we can do better as a pack. Bye. Good morning, everyone. Hi and welcome, and today we're gonna take a look at day 17 part 2. But before we do that, I actually need to fix my glasses. Forgot about it. Not sure about you guys, but I'm freaking blind without my glasses, unfortunately.